All right, good afternoon, everyone. So in this video, we are going to talk about 4.3 partial derivatives. So we already learned the concept of differentiation in Calculus 1. In Calculus 1, the main idea is how to use different technique of differentiation. So same thing, we're gonna use the differentiation technique in 4.3, but we are not just using one variable. So we've been talking about like a function f of x comma y. We are talking about like two variable in calculus 3. And then how would you be able to take the differentiation if you have a two variable at the same time? So that's how we are using the partial derivative techniques. So let me show you the idea of this concept. So again, we are going to focus on calculate and take the derivative technique of the function of two variable. That's the main idea. And I will show you a couple of techniques, higher order derivative, or what the mean of the partial derivative in the three-dimensional space. So it's a very simple concept, just a lot of calculation as you can expect, because we are going to take the derivative. So let me go down here. So briefly, we know the definition of differentiation derivative. So if you have like, long time ago concept, we have the differentiation means. So let's say we have f of x function, and then the limit is basically as x getting approached to a, we believe that there's a certain number L. And also, what does a differentiation mean? The slope at the moment, right? So by taking derivative d over dx of the given function, you can find out the slope of the instantaneous slope or slope at the moment when x is really heading to a, right? So that's the definition of the differentiation. So we are not looking for all different slope. We are looking for particular slope at that moment. So to find out that moment instantaneous slope, we just use the differentiation technique d over dx, take the derivative of the given function. So it gives you the slope of the moment, correct? So we are going to expand this knowledge from calculus 1, calculus 2. Right now we are in calculus 3. What if I have this function now, instead of consider this is the function, we have some points in three-dimensional space, right? So there's x, there's a y, there's a z, there is a sum function x comma y, and then I wanna, there are many, function that is passing through here, this point here. We wanna find out the slope at the moment. So as you see that, it's not just one variable. Here we have a two variable x and y, right? So how would you be able to find out the slope at the moment? So we're gonna still use the derivative concept and also the true definition of the derivative. If you remember, you have a two number. So I'm gonna just get rid of a little bit of here. Let's say we have x plus h. If the gap is getting smaller between x and x plus h, right? You're getting close that moment. So the formula of the differentiation, the definition of the differentiation was this part. Do you guys remember that? Like a long time ago, slope f x plus h minus f of x over h, you can find out f prime of x. So that was the definition of the differentiation. We're gonna use the same definition of the differentiation in terms of the function of two variables. So as you can imagine, we have a two techniques of the differentiation when you have a two variable. So you have to consider this way. One is you are going to take the derivative because we have a two x and y. Honestly, we cannot take them because you have to take the derivative with respect to either x or y variables. So we are going to break them into two different cases. One is you are going to take the derivative with respect to the x variable only. And then you are going to change the x part. One is x plus h, the same as x. And then you're gonna just apply this definition of the differentiation and you can find out the slope. This is the x, xy. Okay, same thing, you can find out the, slope or instantaneous slope at the moment with respect to y variable. Then what do you guys think? You're going to change the y. You're going to find out the gap between y plus h and y. As they're getting smaller, 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 you are getting approached to a certain number. So that's how we are taking the differentiation. So this is the formula to find out both x and y differentiation of the two variable. So one is for the x, then you're gonna change the gap between x's. And then if you're taking the derivative of the with respect to y, you're gonna change the gap between y-axis. Okay, so we call this is the partial differentiation. That's it. Because we cannot take the differentiation technique at the same time applying both x and y. We have to separate them. One is for x, one is for y, and then you are still using the same definition of the differentiation to find out the slope. So we call this as a partial derivative. Nothing is a special, just we have two variable. We have to find out the slope for each x and y variable. So let me show you the example. So I think I need a little bit of space. So I want to find out the derivative. One is for x, one is for y, because we have both x and y. And then they want you to use the definition of the limit, definition of the differentiation. So this is just regular f of x comma y. And then let's find out f x y. We are taking the derivative with respect to x only. So here is a definition. Limit h approach to 0. And then you have x plus h comma y. And then that x plus h is getting close to x. The gap is getting smaller, smaller, and then over h. And I'm going to apply this one into the given equation. So what happened? Very step-by-step work. I think I need to minimize it. So here equal, the first is a limit. And then you're going to apply x plus h into x everywhere. So it is going to be the long numerator. So what happened? What is f? X plus h second, 3x plus h. Basically, you are substitute x plus h into all the x part. Y, 2y second, 4x plus h, 5y minus 12. This is the first term. Am I correct? And then we are going to subtract what? The regular fx comma y, which is x second, 3xy plus 2y second, 4x plus 5y minus 12. So this is very familiar work we did in calculus 1 over h. So let me simplify as much as we can. So that is equal limit all the way line. And I'm going to expand every term. So x second, 2xh, h second, 3xy, because the distributive property, actually negative 3hy. Are you following? I just use all the distributive property. 2y second, 4x minus 4h, 5y minus 12, and we are subtracting the next term. So I'm going to use all the distributive property, negative x second, plus 3xy, 2y second, plus 4x. Whoa, that's a lot. So plus 12 over h. Are we okay? Now let's simplify as much as you can. Can I cancel anything else? Yes. X second minus x second, they're going to cross out. Is there anything else? Yes. Negative 3xy, positive 3xy, plus 2y second, minus 2y second, negative 4x, plus 4x. Is there anything I can cancel? I can cancel, yeah, minus 12 plus 12 plus 5 minus 5. Ooh, so the second term has been canceled. So let me rewrite down the remaining stuff. So that's a limit. We have 2xh plus h second minus 3hy. Is there anything? No, I don't see anything else. Actually, minus 4h there and over h. And I can divide it by h everywhere. That's a 2x plus h minus 3y minus 4. And then this is the limit. I'm going to just use a direct substitution, plug in 0 everywhere. 2 times 0, 0, 3. Oh, my bad. The x is not the h. So we have a 2x, h is a 0, minus 3y minus 4. That's the slope of the moment with respect to x variable. This is fx, x comma y. Are we okay with that? I know it's a long process, but you can find out the slope, by taking the partial derivative technique in two variables. So I'm not done yet. We still need to do the y part, right? So let me change the color. I'm going to change the green. How about that? So y, we are taking the differentiation with respect to y variable. So the second y will be the changing part. So I'm going to just make a long line. So everything is going to be changed. So if you want, I can just write it every formula one more time. So limit, we have f, x, comma, now x stay there, y plus h minus y, right? That's the formula. So what happened? Every y is going to be changing because that's a y plus h. So long line, x second stay there, minus 3x, y plus h plus 2, y plus h second, 4x plus 5, y plus h, 12. So this is the one term, right, which is this part. And then we're going to subtract the original fx comma y. X second minus 3xy plus 2y second minus 4x, 5y. I know it's a long line over h. And then let me expand everything as much as you can. X second, distributive property, 3xy minus 3xh plus 2, y second, 2yh plus h second, plus, actually minus 4x, plus 5h or y plus 5h minus 12. Am I right? And then we're going to subtract all the distributive property, negative x second, 3xy minus 2y second, because you're multiplying -1, invisible -1, plus 4x minus 5y plus 12 over h. Beautiful. We are working on it. And then actually, I need to expand this one more time. Okay, I will do that. But you know what? I will just copy and paste it first. And I'm going to delete this part because I'm going to multiply 2 everywhere. So 2y second, 4yh plus 2h second. I hope there's no mistake. And now time to cancel. So let's cancel x second. Can we cancel? Oh, I forgot the x second here. My bad. So let's cancel whatever it's a plus minus. So x second plus minus cancel. Minus 3xy plus 3xy, bye-bye. Minus 12, 12 cancel. 5h minus 5h cancel. 4 positive negative 4x cancel. What else? Do we have anything else? I do see. Why? I forgot all the second power. Here, second power. So we can cancel this too as well. So every second power has been canceled. The remaining stuff is, let me write there. Oh, sorry. My bad. So let me just try to minimize it. So if we do, we have a limit negative 3xh 4yh 2h second over h. Again, we can divide it by h everywhere. So the limit negative 3x plus 4y 2h. Again, we're gonna plug in 0 everywhere. 1 second, is there anything that I have? Yeah, we have a 5y at the end. So I have
excuse
a
me.
5, yes.
Actually, 5y can be canceled or not.
5y.
Yeah, you canceled 5h with negative 5y.
1 second. Let me just get rid of it here for now. So here we have a remaining stuff. This one, this one, this one, and 5y. Oh, 5h.
Actually,
yeah, you're right. So I delete the wrong one. So I see that this one has to be canceled. 5, because that one was a 5y. So 5y, positive 5y, negative cancel. So we have a remaining 5h. Thank you, thank you. So that's a better, I told you it's a long line. So now we have 5h. Are we good? So now I can divide it by h everywhere. So that is going to be equal limit minus 3x plus 4y plus 2h plus 5. And now we're going to plug in 0 only into the h spot. So what you're going to get? Negative 3x plus 4y. That's going to be 0 plus 5. Gotcha. This is our fy x of comma y with respect to y variable. So that's actually how you take the partial derivative when you have a 2 variable at the same time and we are looking for the slope for each one. So now you might be wondering, Professor Ben, this is a long process. Is there any simple way? Yes, yes. So if you remember in Calculus 1, we talked about a lot of techniques of differential equation. So same thing, we can try it out here instead of using this traditional way. But I wanted to give you the main idea. This is the differentiation, right? You remember that. So I'm gonna keep showing you the shortcut, right? You guys are gonna feel better. So let me go down slowly. Here we go. So here is all the definition of the partial differentiation. So again, partial differentiation only apply to when you have a 2 variables function. Okay, f of x comma y, then partial derivative of f, you're gonna take the partial derivative with respect to x or with respect to y, and then we're gonna write this way. This is the derivative f. You're gonna take the f equation. You're gonna take the derivative this f equation with respect to x. That's what that means, right? It's actually you can write it as a d. This is a df over dx. So that's what they mean with respect to x. And then this is a true definition. Same thing, df of dy. We are taking the derivative with respect to only y variable. And then you are taking only the y changing. So I'm going to highlight different color, x and y. Now, many people confuse how to read it. So I just write down one more time. To find out f sub x of x comma y, we are writing treat y as a constant and differentiate f with respect to x. So sounds like a little bit awkward, but I will show you what they mean. You're gonna treat x as a constant and take the derivative only y variable. So this is actually explain about the shortcut. And I will show you the shortcut very, very soon. This is the very true traditional definition of the partial differentiation, right? So one more time, you're gonna take the f of x first. So it means the same as fx, x comma y. And then same thing, f of y. This means f y, x comma y. Okay. In other words, you can write it differentiation sub x f. So there are many, different, symbols. If you remember, like f prime, d over dx, we talk about many different symbols in calculus 1. So if you look at this meaning, that means this. You're with partial of f with respect to x. If I have f sub y, that means a partial of f with respect to y. Just be aware. And I'm going to show you the shortcut, because now we just look at that shortcut, the method. When you take the derivative with respect to x, y will be considered as a constant all the time. Same thing, if you take the derivative with respect to y, x is going to be constant anyway. We're going to consider that. So I will show you the same question. So this is the same question from example 1. We took a long time to find out each differentiation of x and y. Now let's do this work. I'm gonna do both work. Actually, I need a more space, but anyway, so let's step by step. To calculate, we're gonna calculate df over dx. So that means fx x comma y. Are you following? So we are taking the partial derivative with respect to x variable, and then treat y as a constant. Okay, so let's do the work. So df of dx. So just so we know, we are taking d over dx, x to the second. D over that means 3xy. D over dx, every term, you're taking the derivative with respect to x only. Minus d over dx, 4x, d over dx, 5y, d over dx, 12. Are you following? And as I mentioned, treat y as a constant. So what happened? We know already the answer. This is going to be 2x. And then we only take the derivative with respect to x variable. This one is going to be 3y, because the 3y is going to be considered as a constant. So it's going to be 3y because x become 1. And then this is a constant. You cannot take the derivative. So what happened? It's a constant. If you have a d over dxc, it's going to be 0, right? Constant going to be 0 because now these are constant. So it's going to be plus 0. Now this is going to be -4. And then again, this is the constant 0. This is the constant 0. So what happened? 2x minus 3y minus 4. That's what we just took the partial derivative. We got this is equal to fx x comma y. Let's compare the answer. Up, 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 up. We have the same answer. 2x minus 3y minus 4. 2x minus 3y minus 4. What do you think? It's better. This method is better. Don't you think so? If you want, I don't mind. You can use this traditional way. Doesn't matter. But you already experienced, how to take the differentiation in calculus 1. Just we are expanding the variable instead of 1 word, to 2. So what do you think? It works. This shortcut works. You're gonna treat the opposite variable as a constant. So same thing. We're gonna do the second question. So I'm gonna make a minimize it. And we could do one more, df over dy. So we are looking for the differentiation with respect to y variable. What do you guys think? Treat the x in this time as a constant. Okay, so let's do the work. So df over dy. So d over dy, x a second, d over dy 3xy, d over dy 2y second, d over dy 4x. Actually, you can just calculate it without writing all this work, but I'm writing for you. Plus d over dy 5y, d over dy 12. Okay, let's do the work. This is going to be 0 because x is a constant. Again, please taking whatever the constant, when you take the derivative of the constant, it's always 0. So this is going to be 0 because x is a constant. Again, 3x is a constant, and then the answer, you're taking the derivative of the y. So it looks like just 3xy. So now it's going to be 3x. Are you following what I'm doing here? So many people confused. 3x is a constant. So basically you're having number y, d over dy. What is it? Number remaining. So that's why 3x remaining. Keep going. What happened? Next one. This is the constant. No, this is y. So we have to take the derivative for y. Are you okay? And then what happened? This is going to be 0, right? X is a constant. And then this is a 5, and that is a 0. So we have basically negative 3x plus 4y plus 5. This is fy x comma y. Let's double check the answer. Yes, we have the same answer. So I prefer to use this shortcut. Just treat the opposite variable as a constant and take the derivative directly. So that's the partial derivative technique. Just we're gonna see many different functions. So if you guys okay, can you show me your thumbs up? Are you guys okay with that? So partial derivative, it's a very famous topic. I'm gonna give you one more example. Okay, it looks like you feel like chain rule. So it's the same question. They want you to take the partial derivative. So we have ugly one, sine, but we are not scared of it. We know what to do. So quickly, we're gonna do d f of dx. So f of x, we are taking the derivative with respect to x, treat always y as a constant. Now let's do the work. So d f of dx, you're gonna take the d over dx, sine x second y, 2x plus 4. You're gonna take the sine function's derivative, and then you have to do one more time inside the chain rule. So d over dx, x second y, 2x plus 4. Are you following? So it's the same thing from the calculus one. You're gonna take the derivative outside, and you're gonna take the derivative inside. This is a chain rule. So step by step, I'm gonna get rid of this. So what is a derivative of the sine? That's going to be cosine. Just go back to the differentiation table. So sine will be cosine. You're gonna keep whatever inside because we're gonna retake the differentiation only inside. So now you're gonna take the inside. So what happened? Y treated as a constant, so it's going to be x second y will be what? X second, right? So if you take the derivative, 1 second, x second y minus 2x plus 4. So we are going to treat. So this is going to be, what do you guys think? So you can think about this way, d over dx, x second y, right? Everything is a multiplication, d over dx minus 2x, d over dx 4. So we don't change anything this part. So we still have cosine x second y minus 2x plus 4. And what happened? This one, what do you guys think? 2x, y is a constant, right? Y is a constant, so I don't care. But we need to differentiate the x second power. So 2xy remaining. And then we are taking, this is -2, and then that is going to be 0, right? So basically, that's the answer. This is going to be f of xy. Are you following? So just be careful. This is a constant, and you still take the derivative 2x, and then you multiply whatever the constant. So that's why 2xy remaining. So that's the first answer. I'm gonna minimize it. Actually, I'm gonna bring this one here. And then do. So that was the one answer. Same thing, df of dy. Fy, x comma y. That means treat x this time as a constant. Right? So let's do the work. df of dy. You're gonna take the derivative with respect to y. So same thing anyway, sine x second y, because sine still there's a y, and minus 2x plus 4, and the inside x second y plus 2x plus 4. So this part is going to be cosine x second y minus 2x plus 4. Nothing is special. And this one you have to do d over dy x second y, d over dy negative 2x, d over dy 4. So the finally cosine x second y 2x plus 4. What do you guys think? Which one is a constant? X is a constant. So this is constant. So basically y, you're gonna take the derivative. So you can think about like this one. What is a d over dy to y? 2 is the answer. So same thing. We have x second remaining. Right? And then this one, constant, that's gonna be 0. So this is gonna be 0. And it's also 0. So basically x second, that's only remaining. So this is fy x comma y. That's the answer. So we are getting better and better and better. Just we need to practice more because we never know what kind of function you're gonna deal with. So I'm gonna show you this shortcut, very, very important. So are you guys okay so far? I told you concept is a simple, but a lot of long process calculation. All right, can you guys show me your thumbs up? Are you so far so good? Are you happy? Does it make sense to you? So take some time. Definitely you need a time to practice. I'm gonna do 3 more questions, but very different type of function we're gonna deal with. So quickly practice letter A, B, C. So let's take a look at this. What is going on? So this is a very linear quadratic poly. So we can directly shortcut. So we have f x comma y. I'm going to only look at the x variable because that's what they mean f of x. D over dx. X to the third, x to the second y. You can separate it if you want, but I'm gonna just simplify. So that means 3x second, the first one. And then what do you guys think this one? Y will be the constant, so I don't care. Only 2x remaining. Oh, actually, y is a constant, so I just made a mistake. Y is the constant, so 2xy remaining, isn't it? So if you think about 2x to the second, this is the 2 times 2x. So we consider like a 2 as a y. So that's why 2xy remaining, 2xy, okay? And then the third one, we are taking the derivative with respect to x. So y is also another constant. So what do you guys think? This is y to the second remaining. Are you following? So many people confused. Y second is a constant. So constant remaining because this is x. And the last one is a constant, becomes 0. That's the answer. You can make it shorter. Okay? Just be careful when you have a 2 variable at the same time, you're taking only one differentiation. And then the other one is constant. One more time. Y. So d over dy, x to the third, and xy second. So this time we're going to treat x as a constant. So this is going to be 0. X to the third, what do you guys think? X to the third, it's going to be 0. So 0 plus the second one, x is a 0, x is a constant, and we have a y. This is x to the second remaining. We are taking derivative with respect to y. So the third one, what do you think? X is still there and 2y. And then this is 9y to the second. If I rewrite it, x is second, 2xy minus 9y to the second. That's the f of y, f sub y of x comma y. So you can make it shorter. So I'm going to hold up here. Letter A, are you okay with that? If you really want, I don't mind. You can use the traditional, the long process. It's going to give you the same answer because the shortcut is pretty understandable. So you guys will be okay. Anybody has a question? So you need to practice this one. There's a lot of confusion, but if you practice, it's going to be better. So if you have no question, let's look at the B, letter B. Okay, this is ln. So the ln, if you remember, d over dx ln x, it was 1 over x. So that's the same rule we're going to apply. So fx x comma y. So we're going to do it. It's a chain rule as well inside of the ln. So first, 1 over, right, 3x a second. So I'm going to actually d over dx ln 3x minus xy. So the one is 1 over, right, 3x a second minus xy. And you need to take the differentiation inside 3x minus xy. Are you following? So this one, 1 over 3x minus xy. We are taking derivative with respect to x, 6x, and then y is a constant, y remaining. So that's the answer. This is the second. Oh no, so this is the second. So that's the answer for f sub x with respect to x. One more time, f y x comma y d over dy, we have ln 3x a second minus xy. So again, this is a 1 over 3 second minus xy, and you have to take inside with y variable. So 3x a second minus xy. So if we do, x is in this time constant. So what do you guys think? That's going to be 0. But negative xy, we still have negative x remaining. So that's the answer. Okay, so we good. I'm going to hold up here. Are you guys okay with that? Okay. All right.
X can be canceled.
This one has been canceled 0. So this one, we treat x
I know
as
you can do further simplify, but it doesn't
yeah,
matter.
you can simplify, that's okay. But I will leave it here, that's okay. Because I just want to give you the whole structure. Yeah, you can simplify top and bottom x. You can simplify more. But so far, so good, everybody. Okay, one more. One last one. Can we do letter C? All right, so what do you guys think about letter C? Let me change the color. I'm going to minimize them a little bit because I need a space. All right, so let's just see. All right, this one, as you see, we are going to do both work. F That's d over dx, the entire x e to the xy sine 3x second y to the third. Ooh, 1 second. What is going on? I can separate them as actually, because there's 2 term. Right? And then this one, you have to be careful. Dun, 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 dun. Finally, the product rule, don't you remember? Don't ya, product rule. What was the product rule long time ago? If you have 2 function multiply, f prime g, g prime f. That's how you take the differentiation with 2 functions multiplication. So we're gonna apply this. Actually, I need a space. Okay. All right, so step-by-step work. So first, here, we are going to only consider the x variable, right? So that would be, we're gonna take the e to the x, so f prime. So you can consider f is x, g is e to the xy, but you are taking d over dx with the x, so that is gonna be 1. This is the f prime. And then g prime, we are d over dx, only the x variable. So y is still considered as a constant, okay? So that is going to be what you guys think. So f prime g, g prime f. So in this case, e to the xy, let's think about it. E to the x, if you take the differentiation, it's the same as e to the x, isn't it? And then y is still constant. I can keep it as y because that's a constant. So this is the g prime. Okay, so think about it. So this is, we know that d over dx e to the nx or whatever, you know, x is the same e to the x. I just have a constant, right? So that's still just next to the number. So you can leave it in like that.
Excuse me.
Yes.
Derivative of e the power of xy, right?
Oh,
If y is a constant, they need to put in the front of the
yeah,
xy.
you're right. So nx, we have a 1 over n e to the nx, correct. So we actually need to change it a little bit, my bad. So let me double check, d over dx. So y is the constant, 1 over y, e to the xy will be there because we are following this.
I don't think it's you need to do 1 over, just y, I believe.
Is it 1 over, can you check the, I forgot the differentiation table, but e to the nx is gonna be 1 over n e to the nx. Am I right? Can you double check? I think it's 1 over n. So that's something happening with the product rule. So finally here, d over that one, we're gonna do f prime g, g prime f. So f prime is a 1, g is e to the xy, plus g prime, we have a 1 over y, e to the xy, f is what? Is x. Plus, now we have to second term, only the x variable, so 6x, y is a constant, becomes 0. Am I right? So we finish only this part, right? And then we still have sine 3x second, y to the third. So I'm gonna write there. We need to do d over dx sine 3x second, y to the third. So let me just rewrite them. E to the xy, we have x times e to the xy over y, 6x. And then you're gonna take the derivative outside and inside. So sine will be cosine though. 3x second, y to the third, and inside right? That would be 6x and the inside is gonna be 0. So if you really rewrite it, that's gonna be the answer. It looks a little bit ugly though. So you can combining like term if you want. E to the xy, 1 plus x over y, 6x. And then we do have, I can bring 6x to the front, cosine 3x plus y to the third. So check this answer. I know it's a lot of work, but you can think about it. So one more, we could do y variable with respect to y variable. We have to do that work. So let me make a space. xy, d over dy, xy, sine 3x a second, y to the third. So again, here's a product rule, but you are taking the derivative with respect to y, correct? So y is going to be something different. So if you look at that, f is x, g is e to the xy. So d over dyx, that's going to be apple prime. That is going to be constant, 0, isn't it? Because x is going to be constant. And then g prime, d over dy, e to the xy. So same thing. Now x is the constant, so 1 over x, e to the xy. So that's a g prime. So f prime g, g prime f prime is a 0. So anyway, this is going to be 0. G prime is a 1 over x, e to the xy, f is x. So x cancel, we have only e to the xy. Plus, we still need to do the second term, d over dy, sine x a second plus y to the third. Sorry, it's a little bit of work, but I think we can handle it. So now outside, inside, outside, inside. So e to the xy plus sine will be cosine anyway. So cosine 3x a second plus y to the third. And then you're taking the inside with respect to y, 3x a second anyway, going to be 0. So 0 plus 3y to the second. So if I rewrite it, e to the xy, I'm going to write 3y front, cosine 3x a second, y to the third. That would be the f of y. So think about it. It's a little bit challenging question. Yeah, I have a 3y second, my bad, right? So that's a check. This is a 3y second. So that's the answer. Okay, so double check that work. So this is one of the challenging questions, but you guys learn how to make the shortcut with the partial differentiation. It should be okay. All right, so I'm going to continue to talk about the next concept. Almost done. Partial differentiation, as long as you're able to take partial differentiation technique, 4.3 should be okay. But I'm gonna hold up here. Can we go to the next slide? Are you guys okay? I'm gonna hold up here. Are you guys okay so far? All right, Jason, good to go. Everybody okay? So think about it. We can come back to any question later. I will continue to show you the next one. Actually, I'm gonna skip example 4 because that's a little bit different one, but we're gonna come back this one later. We're gonna come back to this one. Actually, I wanna talk about the meaning of the partial derivative. So this is basically the reading part, but we're gonna just read it quickly. So how can we interpret these partial derivatives? So recall that the graph of function of two variable, we know that it's in 3-dimensional space. So oh, I see. So UN found out my mistake. Yes. So let me just go up a little bit. Thank you, UN, for double check. Well, we found out that mistake too late. So this is actually not 1 over n. So this is n, my bad. So actually we need to do some work again, but you can try it. Just change this one, not 1 over y, just y. Am I right? So you can redo a little bit of work, or I can redo it and I will post it to the discussion board. But basically the question is, when you take the derivative with the exponent function with the nx, you multiply n in the front and keep the e to the nx. That's what UN found out. So I made a little bit mistake. I just considered that as a 1 over n. So we have to change a little bit of the g prime. Same thing here. G prime will be just x, right? According to that. So the calculation, you can try it again, but I'm not going to do it because we know exactly where the mistake is. So please redo the G prime part. So you can, instead of this, just use y. Okay, so this one just going to be y. So then you can find out the better answer. Okay, same thing here. It's not going to be x, 1 over x. It is going to be just x. Okay, so I will leave it at this one for you. Thank you, UN, by the way. So you guys can try to this one more time. Or if you redo this work, can you post it through our discussion board so that we can have a better correct answer at the end? Okay, so maybe some of you guys can try. Okay, so just I made a small mistake. I just consider this one as a 1 over n, but it should be just n. Okay, so I will skip that one. You can wrap up because the process is pretty similar. So anyway, I'm going to talk about the meaning of the partial derivative in three-dimensional space. So if we remove the limit from the definition of the partial derivative, it's exactly the definition of the, the instantaneous slope, but we are not going to use that definition. That's too long. That's too classic. So we've been thinking about like a shortcut. And then here, keep going. This resembles the different quotient for the derivative of the function of one variable, except for the presence of the y variable. So the figure illustrates a surface described by an arbitrary function z equal to f of x comma y. So in this case, they're just talking about the same thing and same thing over again. So we are trying to find out the partial derivative, either this one or that one. So same thing, if you want to take the the derivative with respect to x, you are changing the x again. So we have two different function. This is getting close to your, f x comma y. And then you can find out the moment at that slope, the slope at that moment, right? So this paragraph literally talking about the definition of the slope and how that can be applied into the partial derivative techniques. So I will skip this one. You can just keep reading that, but we practice a lot of the shortcut, but I just wanted to show you more visualize what's happening in three-dimensional space. So we talk about in calculus one, just, one function going, x is there, x plus h, that is close. You can find out the slope that moment. But three-dimensional, we have like a lot of things going on. One is x, y, z. So you can think about this image one more time. But actually, I want to focus on the next one, this one. So what does it mean actually? Partial derivative. So this is something you're going to highlight it. So the df of dx, right? We are taking the differentiation with respect to x. That means that you're finding out the instantaneous slope. In other words, that slope of the tangent line, right? So it gives you anyway slope of the tangent line. That is a passing through the point, right? But at the same time, that slope is going to be parallel line to the x-axis. That's what they mean. So here, I can show you this image. So maybe let me take a look at it. So here, yeah, let's look at this one. So you are taking the differentiation with respect to x. So everything is going to be on the x-axis, so there's some number, it's hard to imagine, but we have x, y, z, and then you are taking the derivative with x variable. So that means you are finding the slope of this tangent line, right? Because you have to touch the point with respect to x. That means this line is going to be always a parallel line to the x-axis. They're going to be the parallel line. Same thing, if you take the derivative with respect to y variable, so they're going to create like kind of like this parallel line. This is going to be parallel line to the y. So that's actually what the meaning in the three-dimensional space. You don't need to actually memorize it, but just be aware. So I'm going to highlight it. df of dy mean, yes, it is a slope of the tangent line that is passing through that random points. At the same time, it is parallel line to the y-axis. So they're corresponding to x and y. So I think this is the short meaning. Nothing is deeper, just that's a parallel line. And then this is a little bit of more reading stuff, but we don't need to really deep down about that. Just be aware. Where are the parallel line? If you take and same thing, if you take the derivative with respect to the z, then this slope will be parallel line to the z-axis. But in calculus 3 here, we are not going to consider the z. So as long as you can take the partial derivative with x and y, that should be enough. But that means parallel to the x and y for each. Okay, so that's actually the same meaning. I don't think the textbook, they don't talk about this a lot, but I think it might be important if you have interested in taking more advanced course, just to read this part yourself. Okay, so textbook is a more focused on the calculation part, but just the meaning of the partial derivative means you're going to find out the parallel line by taking the derivative. So I'm going to go to actually the following question. Okay, so let's go to the next one. I'm going to go down slowly. So in this question, I don't think this one is going to be in the final, but maybe we can think about it. So here we have a plane y equal to 1. Okay, so you have x, y, z. So there is a y that is passing through somewhere here. This is y equal to 1. Right? Because they're passing through the y-axis. And then this is intersected the surface. So there's a surface which is like plate, something like that. It's not really great. So it's going to be something, we have this surface in three-dimensional, and that's the equation. This is z equal to 6xy minus x second minus 2y to the second as a curved shape, as a surface. Find the slope. Okay, slope, and when you see that, directly we know that we're going to take the differentiation. Slope of the tangent, slope to the tangent line to the curve at the point P 1, 1, 3. So 1, 1, 3 is going to be somewhere in this space. I want to find out the slope of the tangent line at 1, 1, 3. So sounds like a little bit abstract, but I will do step by step. So what we're going to do, we know that, okay, y equal to 1 intersect z surface 6xy minus x second minus 2y to the second. So you feel that to find out the slope, we're going to take the derivative of this surface function. So you can think about two, f of x. So in this time, this is a z. So dz over dx, 6xy minus x second, 2y second. Or we can think about dy z, dz, dy, 6xy, x second, 2y second, to find out the slope of each. So let's take a look at that. So I'm going to take the differentiation for each one. So bottom one, what do you guys think? X, so y is a constant, so 6y minus 2x, y is a constant, that's going to be 0. How about the bottom? This is going to be, x is a constant, so 6y. This is going to be 0, and we have 4y remaining. Am I correct? So now we're almost done. Almost done. This is the slope. This is the slope with respect to x or y variable. And then they are going to pass into the 1, 1, 3. So we're going to plugging in 1, 1, 3 into each slope to find out what that is. So if you're plugging in 6 times 1 plus 2 times 1, you will get 4. And then if you're plugging into the second one, 6 times 1 minus 4, 1, you will get 2. So that's the answer. So this is a slope with respect to the x variable. This is the slope with respect to the y variable. So this is the question you can think about more critical and abstract thinking. But think about it. This is a little bit challenging question, but I want you to think. Okay. I don't think this type of question in our quiz or final or next test, but just be aware. Okay. You can find out the slope, between surface and the axis. Okay. So anyway, that's something I want to briefly talk about it, the meaning of the partial derivative. And then I'm going to just go to the last concept. It's going to be very short. So the next one, it's a little bit of work, okay? But again, you might have a more variable, not just 2. It could be 3. So now, what if I have f of x, y, z? There we go. There we go. You still need to take the partial derivative. And the formula is the same thing. If you take the derivative with respect to x, x part will be changing. If you take the derivative with y gap is changing, correct? Z, you can change the z differences. So the formula is the same thing. Again, we're going to use a shortcut, but this is the true classic definition of the partial derivative with 3 variables. Okay, so let me just do one example. So we can take the bottom example. Can I go to the next page? So this is something we are focusing on in quizzes and final, how to take the partial derivative. Can I go to the next page? Can you show me your thumbs up? Are you guys okay? So we already know this definition. So let's really do the work. Again, I'm not going to do this traditional way. We're going to do the shortcut. So here we have 3 variables. So we're going to do step by step. I know that I need a space. So step 1, we take the df over dx. That means fx, x, y, z. So please do so. We're going to take the derivative with respect to x variable. So the first term, we know it's going to be 2x. Everybody okay with that? Yes, yes, yes. And then second one, what do you guys think? The whatever, so this means that y and z are constant. So 3xy, that is going to be, we have to take x and then 3y remaining. Y will be constant, bye-bye, 0. And then I will write it 0 for you. And minus 4, z remaining, because you're taking the derivative with respect to x. 5y is second, they're all constant, 0, minus 12, 4y, 0, minus 3, 0. So basically the answer will be 2x minus 3y, 4z minus 12. Simple, simple, simple. If you really want, yes, you can use this formula, but it takes a long time. Anyway, it's going to give you the same answer. So one more time, df, dy. So that means x, y, z with respect to y. So what do you guys think in this time? Which one is a constant? X and Z are constant. So therefore, X second will be constant, that's a 0. Minus 3xy, 3x will be remaining, correct? And then 4y, there we go. And then y, I don't see that, both of them constant, 0. And then 5yz, 5z second remaining because they are constant in front of the y. And then minus 0 plus 4 minus 0. So therefore, negative 3x plus 4y plus 5z second plus 4 will be the answer. That's with respect to y. Are you okay with that? So it's a shortcut, everybody likes it. All right, one last one, df of dz. So that means you're taking the derivative with respect to z. So in this time, x and y are constant. So keep going, x second, that's my constant, 0. I don't see any z, so everything will be 0 because they're constant. Oh, I have a z, minus 4x. Oh, I have z, so 5y times 2z, correct? And that's gonna be 0, 0. Oh, why I have a 10? That's a 0. The negative 12x will be 0, 4y 0, negative 3 remaining. So negative 4x, I can simplify. 10yz minus 3 is the answer. So it's nothing as a special. We are just using the same method of the partial derivative. Okay, so take a look at. So the rest of the slide is all about practicing partial derivative with the 3 variable. Are you guys okay with that? I'm gonna just practice a couple more, not everything. But can you guys show me your thumbs up? Are you okay with that? So everybody good to go? So I'm gonna go down a couple more examples. So here, let's take a look at not the A. I think you guys can try letter A yourself. How about the B? Let's do the B. Letter B. So we're gonna step by step. All right, so we're gonna do the second one. So here, what do you guys think? So we have xy tangent x second plus z. And then what's happening? You have inside and something going on. So it looks like more than 2 variables are multiplied to each other. So you might be considered the product rule. So in this case, I will consider, so first, fx, x, y, z. I'm going to separate 2 things, okay? xy times these 2 functions. So maybe we can consider the product rule, and obviously y and z in this time are constant. Okay, so if I have xy, so f prime xy is f prime with respect to x, so you have a y, correct? And then g is a tangent x second plus z, and g prime will be second square, right? Because you take the derivative of the tangent, that's going to be second square, x squared plus z, and you have to do one more time inside 2x, z will be the 0. So we have it, we have all the answer. So basically f prime g, g prime f, with respect to everything, the x variable. So we did that. We found out f prime g prime. So the answer will be f x y, right, times f prime and g, right? F prime g, g was tangent x second plus z plus g prime second square x squared plus z, and then 2x, that's a g prime, and f is xy. So if I rewrite it, it is going to be xy tangent x second z plus, I'm going to bring 2x, this one, 2x second, y second square, x squared plus z. You can leave it like that. Okay? So you can do the similar work for y. Okay? So let's take a look at it. Oh, I have a bad one thing. So apple prime. So this is apple prime. My bad. Apple prime was y. Did you see that? So it should be no x there. Apple prime. So one more time. This is apple prime g. These are g prime f. My bad. So that's better answer. Y. Here we have a y. Only y. Thank you. All right, are you guys okay with that? So that's for f with respect to x variable. I can do the y variable one more time. We have to do all three, x, y, z. All right, let's do the y. F, y, x, y, z. So same thing, d over dy, but we have to do in this time the dy. So these are, so if I rewrite it, these are all the respect to the x variable. So these are, I already took d over dx. But now I'm going to do the similar work, but dy. So f is xy. So apple prime, that means d over dy. What is that? X remaining, correct? Same thing, g, tangent x squared plus z. And then g prime, obviously secant second. But we don't have to because there's no y. So everything is a constant. So what do you guys think here? We don't have g prime. That's going to be 0. So I'm going to write it because there's no y. So that's it. Are you okay with that? G prime is 0 because we are taking here everything with respect to the dy. So x and z are constant. So these are going to be just 0. Constant will be 0. So the answer will be here. Apple prime, we have x, g, x times tangent x secant plus z. And then g prime is 0, so 0. That's the answer. This is for sure, we got it. So this is the answer for the above. Are you following? So very, very important. It's very easy to make a mistake. Okay? So this is here. This is the second one. And let's do the last one, z. Okay, so f, z, x comma y comma z. So that means d over dz, f prime g, g prime f. So let's do the work. I'm gonna make a space for you. So here, we have to d over dz. So f is xy. What do you guys apple prime? In this time, xy will be the constant. So the apple prime will be 0. G was tangent x second z. G prime, okay, we have a z. So we can take the derivative outside and inside. So the second, x second plus z. And inside, x second will be 0. Z in front of that, it's going to be 1, so 1 remaining. So therefore, this one, apple prime is a 0, so nothing is there. So 0 plus g prime, secant square, x squared plus z times xy. That's the answer. So if I rewrite it beautifully, xy times secant second, x second, z is the answer. Wow, we made it. So that's for letter B. Are you guys okay? So definitely practice is important because that's so easy to make a mistake. So I'm gonna hold up there. I'm not gonna do a lot of questions, but are you following here? Are you guys okay with that? Those XYZ? Wow, I talk a lot, so I'm very thirsty, but I hope you guys okay. Jason got this, Ewan got that, everybody got that? So practice, please. So letter A and C. C, you can think about it. So it's the same strategy, just it's a 3 variable. Okay, so I'm gonna do more practice, just 2 more, and then I'm gonna wrap up. So let me go down. So try letter A and B yourself. Okay, I'm gonna go down slowly. Can I go? Yes. So here, okay, this is the same type of question, just we have to do X, we have to do Y, we have to do Z, but in this time, you feel that this is the quotient rule. We're gonna use quotient rule. So if you remember in calculus 1, you have f of g, 2 different functions, f prime g, do you remember, minus g prime f, and g to the 2nd power. Literally, we're gonna use this one. So actually, I'm gonna do this one. It takes a little bit of long time, okay? So let's do. So this one, we're gonna use a quotient rule. So step by step work. So we're gonna do f of x, x, y, z. So d over dx, correct? And I have f prime g minus g prime f of g 2nd. So we have to find out this one first. So I'm gonna make a little bit of space here. So f, we're gonna consider all the numerator part. So x 2nd, y, 4xz plus y 2nd, f prime. So everything this one with respect to the d over dx. Am I correct? So therefore, this is a 2xy. Am I right? Yeah. And then z is a constant. And then negative 4z, y is a constant. That's going to be 0. So that's f prime. G is all the bottom. X minus 3yz. The g prime, right? This is with respect to x, 1 minus 3y. Oh, my bad. This is no x, so that's 1. 1 is only the g prime, correct? Because y is a constant number. So that's going to be 0. So that's something we got. So therefore, we have f prime 2xy minus 4z, f prime g, x minus 3yz, minus the g prime is 1, f x 2nd y minus 4xz. Ugh, I knew that I need a space. And then let me minimize it. Can I? All right, so then the f is plus y to the 2nd over g 2nd power. So x minus 3 yz to the 2nd. So you can expand it at the top. So 2x 2nd y minus 6x y to the 2nd 0. So all the rainbow minus 4xz plus 12 yz to the 2nd. And then the rest of them minus xy. And then I'm going to use all the distributive property plus 4x 2nd z minus y to the 2nd. Oh, I don't know why I have the 2nd power. Sorry, my bad, because there's no x. This is just x, y, x, z. So that's what it is. And then something cancel. These two cancel. So the numerator, if I rewrite it, 2x 2nd y. Yes. 2x 2nd y. Let me double check. Do I have any mistake here? Yes, I put all the wrong number. Don't you see that? So the f is x second power y minus 4xz. Yeah. So here's second power. So that's why I was always weird. We can combine these two, correct? So that's going to be x second y. And the ugly one, negative 6xy to the second z plus 12y z second minus y second over x minus 3yz entire second. That's the f sub x xyz. That's it. So this is the same question from our textbook. We got the same answer. Yeah? Am I okay? So check it out. All right, so can we do the next one, Fy? So let me double check the Fy. What we're gonna do, we have the same question. So I'm gonna minimize it, change the color, Fy. So that means d over dy. We're gonna do the same quotient rule. Sorry, it's a little bit of complicated, but you can wrap up d over dy. So now f is x second y 4xz plus y second. Apple prime, we have to take the derivative with y variable. So xy, x second. There's no y, 0. And then 2y. So basically apple prime, x second plus 2y. Okay, good. How about the g? We have x minus 3 yz, g prime, x is a constant to 0, and then we have a 3z, so basically negative 3z. So that's the, with respect to y. So now we're gonna wrap up. So here, apple prime, apple prime g, g prime f. Why I have a apple prime g, g prime apple prime, x second plus 2y, g, x minus 3yz minus g prime, negative 3z, and f is a pretty long. So let me minimize it. F is x second y minus 4xz plus y second over x minus 3yz to the second. Again, please expand all the numerator we have to do. So if you tried it, expanded it, x to the third, 3, x to the second, yz, plus 2xy minus 6y second z, correct? That's the first part. And then this negative change to positive 3. So positive 3z x second y, and positive times negative, negative 12 xz square, positive 3zy to the second over x minus 3yz second. All right, can we simplify any number? Is there any combining like term? I do see, okay, this is cancel, plus x second yz, bye-bye. And also we can combine these two. They're same y second z. So it's gonna be negative 3. So if I rewrite them, x to the third plus 2xy. And then I have the yellow part, they're gonna combine negative 3, y second z, and I have 12xz second over x minus 3yz entire. That's the answer. Geez, that's a lot, I know. So I will do one last one for today. Are you guys okay so far? So we have to do the one more, the z, d over dz. So f x second y 4xz plus y second. Apple prime what? Everything is a constant, so 0 minus 4x plus 0. Oh, that's negative 4x. g x minus 3yz. So g prime negative 3y. So we have it. We have it. The rest of thing, you're going to plug it in. Right? So we're going to do f prime is what? Negative 4x g negative 3y minus, oh, my bad, it's a g prime. So g, it should be g, my bad. So x minus 3yz. So that's f prime g. And g prime negative 3y f. X second y minus 4xz plus y to the second over x minus 3yz to the second. Are we okay? Almost done. Expanded at negative 4 x second plus 12 xyz plus 3y second x second, because I use a distributive property, plus 12 xyz plus 3 y to the third. Hopefully my calculation is okay. You should double check. So anyway, when I did this work, what you got? Is there any cancellation? So negative 4x second. I do see 12 xyz. Actually, they're positive. One should be negative. Oh, yeah. This one should be negative. Why? Because a positive times negative is negative. So my bad. They're actually canceled. And I don't see nothing is a cancel. So therefore, the answer should be, the final answer will be negative 4x second, 3y second, x second, plus 3y to the third, x minus 3yz second. That's the answer. That's F sub G.